I started recording. This is a video that's just going to go over all the tests I already handed you back in order. We're going to do as far as we can today and tomorrow. Anything I don't finish, I'll do in my own time. So don't worry. I'll put everything on a YouTube video or 3 separate YouTube videos. All right, first one. I need to name two coterminal angles, one positive, one negative. So, coterminal means they're 360 degrees away from each other because you would do a full circle and land in the same spot. So, with 600, I could add 360 and I'll get 960. So, that'll be a positive one. That's great. But I also need one that's negative. So, since I need one that's negative, I'm going to do 600 minus 360. That's going to leave me 240. Now I'm going to have to do that again because I got to get to the negative. So, minus 360 one more time. That's a negative 120. So negative 120 is a coterminal angle. Technically, I could do it infinite amount of times, but I just asked for one positive, one negative, and I'm done. This one, we're changing the following thing from decimal to degrees, minutes, seconds. Think of degrees, minutes, seconds as hour, minutes, seconds. For example, if I had 12.5 hours, I hope you could see that would be 12 hours and 30 minutes. Well, how do I get 30 minutes from zero point 0.5? I do 60 times 0.5, and that would give me 30. So in this case, I'm going to multiply my decimals. So I have 18 degrees, and then I'm going to do 0.27 times 60. 0.27 times 60. That's going to be, is it 16.2? Let me just check on my calculator so I can be clear. Good. So that's going to be 16.2. That's 16.2. So then I have 16 minutes. Now I'm going to take that zero point 0.2 minutes, so zero point 0.2 of a minute, and times it by the 60 seconds in a minute. So zero point 0.2 times 60 would be 12. So I'll put a 12 here. So it's 18 degrees, 16 minutes, and 12 seconds. Over here, we're going to do the reverse, which is going to be dividing. So I know 45, technically over 1 because it's per degree, plus for every 18 minutes, that's out of 60 minutes in an hour or minutes in a degree, plus out of 54, it's going to be 60 times 60, which is going to be 3,600. You could type that in a calculator straightforward. You don't even have to put parentheses because division PEMDAS will do it correctly for you. And I got 45.315. Of course, to check your answer, you could always just do the reverse of what I just did and see if it gets back to this. All right. From the terminal side of an angle, I can't believe that's been there the whole time, of a standard position is drawn to the given point. Give the 6 trig functions. So since this is 12 comma 5, I know it should be in the first quadrant, where I go 12 to the right and 5 up. There's some point over here, 12 comma 5. If I draw an angle or a line from the origin to that point, I get this diagonal line, and this forms a nice little right angle. Because of this, I can also confer how long this line is by using Pythagorean theorem. This is a Pythagorean triple, which is 13. Common, those are set of whole numbers that will make that works for a right triangle. So 3, 4, 5 is the most common one we have. There's 5, 12, 13. And another one you might see is 7, 15, actually, I don't, maybe it was 8. Who cares, actually, you know what? But no, those are two common Pythagorean triples. You could also always multiply them. So you could make it 6, 8, 10, and that would still be a Pythagorean triple. Or you times it by 3, 9, 12, 15. That would also be a Pythagorean triple. All right, either way, now we're going to do our sine, cosines, and our angles here. So you could either think of it as SOHCAHTOA, so opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Or you could also know it because it's positional. Sine is going to be y over r, which is our hypotenuse, which in this case is going to be 5 over 13. Cosine is going to be x over r, which is going to be 12 over 13. And tan is going to be y over x. I always think of it as slope, y over x, or rise over run. So that's going to be 5 over 12. And then we're going to use our reciprocal ones, which is cosecant, secant, and cotangent. Good. And then in this case, it's going to be r over y, or 13 over 5. It's going to be r over x, which is going to be 13 over 12. And it's going to be x over y, which is going to be 12 over 5. Keep in mind, a side note, if you're doing your sine and cosine, if somehow you get a number bigger than 1 or less than -1, something went wrong. So be careful. Go ahead. Mm-hmm. Yeah, I can't give r as a point. That's when you get that's where you get r first, I guess, in that case. All right, let's do our next one. I guess this is where you could get r technically in this one. So, find the other five trig functions where cosine is -4 over 5 and is in between 180 and 270 degrees. Because it's in between 180 and 270 degrees, I know it's in this third quadrant. So I'll zoom in, I guess, relatively. And since I know cosine is -4 over 5, first of all, it makes sense as negative. You know cosine should be x over r, which is -4 over 5. So I know I'm going -4 to the left, and I know whatever my r is going to be 5 long. Your theta should always be touching the x-axis, okay? So now I need to find this one, which hopefully you can see that this is end up being a Pythagorean triple. But be careful since I'm going down. This is going to be negative. Okay. Now let me get the five other trig functions. Sine, which is y over r, so -3 over 5. Cosine, they gave me that, so you shouldn't be embarrassed if you get that wrong. Tan should be y over x, so -3 over -4, but that cleans up to be 3 over 4. So if it's a multiple choice question, no, it will be 3 over 4 positive. And then what? -3 and negative? I can't because -3 over -4 is technically correct. I would put the sine, I'll put the cosine, I would put the tangent, and I would put whatever cotangent is going to be. If to be honest, of how I would make the question. So cosecant is going to be this is 5 over -3. Remember, the negative could go in the front of the fraction, doesn't really matter. Secant is just a flip of that, so -5 over 4. And cotangent is going to be 4 over 3. If I were making a multiple choice, I'd probably put the sine version, the tan version, the cotangent version, and probably the secant version. Yeah. Typically, if I were to make the multiple choice question, I use 3.14. But I'm not going to put something where it's like off by a couple decimals. So it should be like clear, oh, this is the right answer, even if the rounding's a little off. Like I want to put something like 13.2, 13.3. Which one is it? Like I'm not going to do something like that. All right, evaluate round to two decimal points. In this case, I need to evaluate this. This is not a unit circle one. And I don't think we learned a unit circle by this one. So we're just going to use the calculator, which makes sense. We didn't learn a unit circle in this section. So we're going to do this one. So 12.5, I have to put it in my calculator. So I'm just going to trust you. What is it? 0.47. You just have to type it in. And then cosecant. Since it's cosecant 59, you need to do 1 over sine 59. It is not sine 1 over 59. Yes, you're right. I'll put that as one of the fake options to test you. Right? Yeah. So 1, that's not this part. Oh, but that'd be a good one to put as a fake answer too. Sine -1 on this too. Yeah. So here, yeah, that's a good idea. For this one, if I were to make a multiple choice, this is the correct way. One fake answer would be like sine 1 over 59. Another fake answer would be sine -1 of 59, which would say error. And then I don't know what I would do. I'd probably do cosine or something. All right. That's a different thing, yes. All right, next one. Give me all the measures from 0 to 360 with the equation given function. So here, I'm still trying to get this TI-80 to wake up. But here, sine of theta equals 0.408475. So in this one, I'm going to rewrite it as theta equals sine -1 of 0.4875. Um, the thing is still not showing up. 29.17. So 29.17, I'm just going to round it to 2. So 29.2 degrees. But I need all the angles that fit. So in this case, it's always all students take calculus. In this case, this is a positive one. So that belongs here. Since I'm doing sine, I need this section here. This section, to figure out, I would take whatever angle I have and do 180 minus the angle I have. If it was in the third quadrant, it'd be theta minus 180. And then the other one would be 360 minus your theta. You could do it that way, yeah. And then the next one is what is it? 0.8 in this case, yeah. So 150.8 degrees, okay? So both angles will give you that measure, that sign. This is multiple choice, so I'll choose for you. 1 decimal point. Oh, because this is sine and because this is positive, I know it has to be in the first quadrant because everything's positive in the first quadrant, and the second quadrant because I know sine is positive in the second. If it was tangent, I would do first and third quadrant. All right. Wait a second. Yeah, that'd be fine. I apologize. If you had tan, it should be plus 180. All right. Let's say it was 29 and I gave you tan, right? It'll be 29 plus 180 to get the angle here. That's what my mistake. All right. Give the exact values of 6 trig functions of the given angle. Oh, these are the special right triangle ones. All right. So a special right triangle, in by definition, let's say it was 60 degrees here and 30 degrees here, is going to be a root 3, and 2a. But what we're concerned about is what happens when our hypotenuse is 1, like a unicircle. Because our hypotenuse is 1, this will be 1 over 2, because this will be half times 2 equals 1. And this would be 1 over root 3. You could just remember it. Yeah, or look at the unicircle. Or just know what you need to do. So I'm just telling you where it's coming from. Uh, Technically, if this is 1, no, is it half of root 3? Am I wrong? Oh, it's root 3 over 2. You're right. My fault. Because a is 1/2, so it should be root 3 over 2. Okay? So, in this case, because we're using a unit circle, we can simplify our thing. Sine is just y value. Because r is 1, you don't need to apply the r. So that's going to be root 3 over 2. Cosine is just the x value in a unit circle. So that's 1 over 2. Um, tan is still y over x. Good, root 3 over 2 divided by 1 over 2. Because they both have over 2's, I could cross those out. So it just ends up being root 3. Then I have to do my reciprocals. So cosecant equals 1 over y, or in this case, you don't have to. Yeah, however you remember it, it's up to you. Which ends up being no, but I'm happy to give you a blank one, but I'm not giving you a filled out one. Secant equals whatever 1 over x is, which ends up being 2. And then cotangent would be x over y, which is technically 1/2 over root 3 over 2, which is technically 1 over root 3, which cleaned up would be root 3 over 3. Okay. All right. Yo. Then you have to, yeah, fix it because roots shouldn't be on the bottom. All right. Next one 135. Good. And just as a reminder, where it comes from. Again, you don't need to remember where it comes from, but I'm just mentioning it. Technically, it's A root 2 in a 45-degree angle in a 45, 45, 90. 135, if I do the reference, 180 minus 135 would give me 135. Or 180 minus 45, my bad, equals 135. So I know it should be related to 45 degrees. So if this was 1, then we could figure out this would be 1 over root 2, which has to be fixed to root 2 over 2. And this is the same thing, root 2 over 2. But as someone said, this is in the second quadrant. So all students takes calculus. In this case, this S means only the sign and its reciprocal, cosecant, should be positive. So for sine, it's going to be root 2 over 2. For cosine, I should know it should be negative root 2 over 2. For tan, which is y over x, is root 2 over 2 divided by negative root 2 over 2. But these are the same thing on top and bottom, so this just becomes negative 1.
But is it always one of these cases?
Is it always, if you're using the unit circle, is one of these cases, yes.
So it can't be.
It can't be just 2. Which one's positive, which one's negative? No, y is positive, x is negative. Because you're in the second quadrant, which is pointing up. No, you're in 135 degrees. It's not like an option. Yes. In the second quadrant, it's negative positive. No. Secant equals negative root 2. And cotangent equals negative 1. The reciprocal of negative 1 is negative 1. So that makes it easy. And this is just a blank unit circle I left you guys. There's a lot of videos with unit circles. I'm not going to spend the time here doing unit circle. All right, next one. From 12.5 to 12.9. This was like solving right triangles, law of sines, law of cosines, I believe. So this one, I need to find angle A. Yes. 12.5 to 12.9. Their side is 5, which is good to know, but in this case, since I'm looking for the angle, it's not necessary to me. Not even that, too much on that one. So what we're going to do is we're going to identify 12 as our adjacent, and we're going to identify 13 as our opposite. Because remember, the right angle dictates what's the opposite. You use law sines and low cosines when it's not a right triangle. Otherwise, you're just using normal triangle. So in this case, I have adjacent and I have opposite. So I need to think. I have adjacent and opposite. Which one uses that? So katoa, that's going to be ka. So cosine of my mystery theta equals 12 over 13. Yeah, but it's adjacent and oh shoot, this is adjacent and hypotenuse. My bad. That's totally my fault. 13 was the hypotenuse. It's opposite of the right angle, which makes it the hypotenuse. That's why I was thinking opposite. Totally my fault. Yeah, but I'm just finding angle A. So I'm gonna find cosine of theta. You could put cosine of A, capital A. I don't care how you do it. Of 12 or 13. I need the cosine to go away, so I'm gonna do theta equals cosine -1 of 12 over 13. Not tan, cosine. So I'm sorry. It should be opposite over hypotenuse. I fixed it up here. I apologize. Opposite hypotenuse. This one over here is the adjacent. Oh, I'm sorry. This one. This one over here is the opposite. My bad on that. Okay, so yeah, we're gonna go inverse 12 divided by 13 equals 22.6. So it's 22.6 degrees. I don't know what this shouldn't say B. This should say A. This is probably the makeup version. That's why probably. If you did tan, if you wanted to use tan, you would have to use opposite and adjacent, which would have been 5 and 12. But that should give you the same answer. It said find A, we'll find A. Why it says B? Probably because I'm guessing I made a makeup version where instead of changing the whole question, I just said find B instead or something. All right, next one. We're going to find little c. So that's this side over here, okay? So I need to find this side. This side is my hypotenuse side. And this side over here, since 37 is standing over here, this is my adjacent. So this, incidentally, uses cosine again. Cos 37 equals adjacent, 11, over hypotenuse, x. We need to clean this up, so I times x on both sides. Then I have to clean it up again. I'm going to divide cosine 37 on both sides. So 11 divided by cosine 37 is 13.77. I'll just put 13.8. Number 3, find B. In this case, this is not a right triangle. So now I'm forced to use a different formula. It is a scaling. What's up? This is going to be either law of sines or law of cosines. You can use a law of sines. Usually that's your first choice should be use law of sines. You can think of it like that. This is how I'm going to think about it. When I have a pair of angle side, so in this case I have A and its opposite side, because I have that, I could use law of sines. Law of sines. If I have a matching angle side, I could use law of sines. Otherwise, I'm kind of forced to use law of cosines. This is law of sines. I'm not. You could use law of cosines, but it's like more complicated. So I suggest using law of sines. And you could use law of sines because I have angle A and side A. As long as I have a pair of angle and side, so 26 over sine. Well, let me write the formula first, just for sake. It's going to be lowercase a, the side of A, over sine capital A. In this case, it's going to be lowercase b over the sine of B. Depending if you look online, sometimes they put the sign on top versus bottom. It doesn't matter. It still works regardless. Since we're looking for B, we should put B. It also it works for C also, which is lowercase c sine C. But since I only use these two at this moment. So sine 26 goes with sine 88, and that equals. I know this is 16.1 over sine capital B. I don't know what it is, but it's not just capital B, it's sine capital B. A little cross multiplication. 26 sine capital B equals 16.1 times sine 88. A little division. Sine B equals 16.1 times sine 88 divided by 26. And a little bit of inverse because I got to get the B by itself. B equals sine negative 1 of this thing over here. 16.1 times sine 88 over 26. You could put it piecewise in your calculator. What I suggest to do when you do your calculator, here's my calculator. If I were to do it piecewise, so let's say if I did, let's see if that's true. 16.1 times, I just gotta make sure I'm in degrees. 16.1 times sine 88 divided by 26. Yes. Divided by 26 equals some crazy decimal. To minimize like rounding errors, what I do is sine negative 1, and I'll click second, and the negative button over here will give you the answer of the previous section, so you don't have to retype it. You click second negative, it'll give you the answer. 30, I'm getting 80.23. That's why the rounding, be careful with the rounding. That's why I like either do it all at once or whatever. Yeah, it's recording right now. So it's 38.2. That's going to be 38.2 degrees because it's A. Well, let's see. Law of sines, remember, you need a pair of matching angles and sides. Right now, I have this angle. Right now, I have this angle. Can I find angle B? Good. Is it 90? All right, this happens to be 90. That's incidental. I'm surprised it's 90. So if it's 90 and I want to find little c, which is across of big C, I want this guy over here. So because I want little c over here, I got to do my math. You can use law of sines. In this case, because there's a right angle, you could just use normal trigonometry. That's perfectly fine. That's perfectly fine. So in this case, I could use normal trig because it's a right angle. Let's use law of sines just to see if it works no matter what. So I have this pair. So 27 over sine 90 over, I need to do this pair. Good. I'll put it as lowercase c, sine 51. Luckily for me, when it's this one, all I have to do is times sine 51 on both sides. And hopefully you could also notice, what is sine 90? Does everyone remember? 1. So sine 90 doesn't even matter, but let's say you didn't notice that on the test, you could still type it in. Oh, 90. Equals 20.98. So let's say 21. It rounds to 21. How much more time I got? Is it over? 3 more minutes? Let's do at least one. Oh. Yeah. I'm going to stop it because I don't want the video to cut weird. Yes, which I just rounded to 21. Let's stop it.